Hello everyone, my topic is what happened for sodium chlorine system at high pressure. In this video, I will some new fantastic discovery in our research. At high pressure, almost every material will compact itself to a denser form. Chemical bonding and electronic structure will change, valence rule will fail. The old rules are not good for high pressure, so new rules need to be explored and built up for high-pressure field. As early as 1925, Britain physicists J.D. Bono have pointed out that every material will be a metal at sufficient pressure. Actually, experimentalists prove this predict on many materials. For example, oxygen. People found the oxygen will be a metal since 1906 gigapascal. Silicon, metallized since 20 gigapascal. For germanium, 12 gigapascal. Sulfur, 90 gigapascal. But for sodium, it gives a totally different story. At about 200 gigapascal, sodium changed to a transparent insulator. This discovery was published in Nature journal in 2009. We choose sodium as one of the elements for our research system. The other element is chlorine. So firstly, let us see the two elements' electronic configuration. For sodium, with one lone electron at the outermost cell, it's 30 to lose that lone electron to have 2p cell as the outermost one. For chlorine, with 70 electron at the outermost cell, 3p cell, it wants to get more electron to fill up its 3p cell. So when sodium meets chlorine, they make happy for each other by transferring one electron, one sodium atom, to one chlorine atom to create sodium chloride. Sodium chlorine, as a typical ionic compound, is playing the ionic bond perfectly. So always used to be an example in textbook when talking about ionic bond, ionic compound. It can also be used as an inert calibrator in high-pressure X-ray diffraction experimental because of its simple phase diagram and the stability of the second phase. That's just one phase transition for sodium chloride at high pressure from FCC to BCC structure. All of study about sodium chloride shows no new phase is found after the BCC structure. For a long time, sodium chloride is thought as the only one compound between sodium and chlorine. Is it true? Is it really so simple for sodium chlorine system, even at high pressure? Our research gave the answer, no. This is the phase diagram for sodium and chlorine system at high pressure. Before we do our research, you could find at high pressure, sodium have abundant phase transition from the simpler one BCC, FCC structure to complex one Ci16, Ti19 till HP4. For chlorine, just only one phase transition to a metal chlorine, except two phases of solid chloride. There are a white-black field between sodium to sodium chloride, between sodium chloride to chlorine. So both theoreticians and physicists, both theoreticians and experimentalists know nothing about this field. We do variable composition structure searching at high pressure for this system by Uzbek code. And WASP code is used to relax the every stable structure found by Uzbek. And we found some interesting structure with different components. The most fantastic structure present in sodium chlorine 7 and sodium chlorine 3. All of these structures have not been mentioned in any paper or any textbook before. This is the structure of sodium chlorine 7. You could see the sodium atom sits at the corner of a cubic cell, and 12 chlorine make up a chlorine oxygen. In the center of oxygen, there's another chlorine. Sodium chlorine 3 have the similar structure with sodium chlorine 7. The only difference is just the substitute the center chlorine by sodium. This substitution doesn't change much about the lattice configuration, even lattice parameter, and the nearest distance between atoms, which means at high pressure, sodium and chlorine ions has a similar size. Here are the bond structure and the density of states fingers. Bond structure finger, we could see some energy bond go across the Fermi level for both sodium chlorine 7 and sodium chlorine 3. From the density of states finger, we find the densities of states near Fermi level are not zero for both of two compounds. So that means two compounds are metals. Actually, they have similar lattice configuration with type 2 superconductor A3b, but both of them are not superconductor. Why? Let me explain this. In A3b superconductor, A is usually transitional metal atom. Its d electron donates electronic structure near the Fermi level. For sodium chlorine 7 and sodium chlorine 3, from the projected density of states, we could see the contribution of density states is mainly from chlorine 2p electron. So no d electron in both of them. So no superconductivity. The two map are electron localization function finger. We could find for the ultrahydral chlorine, it has a Torrindo maximum, which means the chlorine ion cell is not closed, both in sodium chlorine 7 and sodium chlorine 3. In sodium chlorine 7, there is another chlorine, the center chlorine. For the center chlorine, it has spherical maximum, which means a closed shell for chlorine ion. So in sodium chlorine 7, there's two kinds of chlorine. From the beta charge calculation, we find a similar thing. In sodium chlorine 7, for the center chlorine, it donates electron just like sodium does. For the exohydral chlorine, it obtains electron just as chlorine usually does in other compounds. So two kinds of different chlorine in different positions plays different roles in the sodium chlorine 7. I want to mention, before cubic sodium 3, at lower pressure, we have found another sodium chlorine 3, a tetragonal structure, and it's an insulator. Besides sodium chlorine 7 and sodium chlorine 3, in the field between sodium chloride and sodium, we find some sodium-rich compound with different components, including sodium 2 chlorine, sodium 3 chlorine, sodium 3 chlorine 2. We predict their structures and their phase transition with pressure. In conclusion, we predict some exotic structures, exotic compounds which are not stable at atmosphere. but at pressure, they come out. And we reconstruct this phase diagram. Can you imagine? For sodium chloride, salt, have so many relatives with such rich and colorful structure. A brand new chapter about sodium chlorine system has been unsealed by us.